So hey guys, this is Biswajit and welcome to my YouTube channel. So if you have not watched the previous video, just go and watch the previous video. I have explained the problem statement over there. And in this video, I'm going to talk about the Jupyter Notebook file, the coding part that I have done. As you can see, I have already uploaded the coding part. Okay. So this is the file upload structure. This is the model. This is the pipeline, static, proc file, readme, requirements or txt. And I'm going to upload the Jupyter Notebook file also. I can see that it is not there. I'm going to upload that as well. So this is already available. This is deployed in Heroku, and this is a working project. You can use it. Just go and download from the zip file. So let's start with the problem statement. So I have the Jupyter Notebook file over here. So I'm gonna fire up my terminal, conda activate Python 3.9. Okay, Jupyter Notebook. Yep. So this is the Jupyter Notebook file that I was talking about. Yep. So actually in the previous video I have not commented on the code, but in this video I have written some few comments on this. All the machine learning videos that you have watched, they follow the same pattern, like import the libraries, get the dataset, do some kind of pre-processing, do visualization. I have done everything except the visualization. First of all, we'll start with the importing the required libraries. So these are the libraries that I have used in creating this particular project. The problem statement was we are supposed to predict the income class of the person, or should I say whether the person earns greater than 50,000 or it is less than 50,000 given the dataset. So these are the libraries that we use. So this is Numpy to handle mathematical calculations. These are Pandas to handle the data in a proper, efficient manner. Then the matplotlib, this is done to like to print some little bit visualization, like some kind of charts. Okay. Then I've used the OS module. Then there is something which I'm gonna show, beautiful soup, Caleb. Okay. So this and this all are required for our machine learning. Okay, Sklearn for pre-processing machine learning, and this is for date time, to generate date and time, so that file name generation, this is used for file name generation. Okay, and this is to save the model. Okay, so let's run this. All files will get imported. So this is the code which is used to download the data. Okay, so the data is already available in this particular link. So as you can see, the data is already available. I will share this link with you people. So this is the data, adult.data. This dot names, it contains this detail, the names file, and adult.test, it is the test data. So I have downloaded all three of them. Okay, so I have downloaded the training data, and I have downloaded the test data, and I also have downloaded the names file, right? Because you might wonder what that names file does. So the adult.names file, it contains this data. I have printed the data over here. Okay, so I have downloaded the training data and I have downloaded the test data. Let's execute this. It is going to take some time. So I'm going to fast forward this video because this takes some time to execute. Okay, this was done a little bit quicker than I thought. So this is the description of the data set that is present, and it says which algorithm gave this error, which algorithms. So there is 3C4.5, it gave this kind of error. So we are not interested in this as of now, and these are the columns. Okay, age, work class, then education, then this FNL WGT. I really don't know what this particular column means, because it's just written continuous, maybe some kind of data that is provided, but I'm able to recall this education number, then marital status, then occupation. Okay, So this is the metadata of the data. Okay. So what I have done, I have assigned column names, this names, okay, I have copy pasted and I have assigned the names. Okay, first of all, let me show how the data looks like. Okay, so this is the train data, this is the train set. Okay, yep, this is the train set. So this is the data, that we read. Okay, but you can see the data doesn't have any column names. Okay, so we need to give the data column names. These are the column names that are given to us. So what I did, I saved all the column names in a list and I just used this to assign the column names. Okay, so for train set dot columns, column names, column labels, and all these column labels got assigned to this data frame. Okay, and I'm doing the same thing for the test data. Okay, and I'm going to show you how the data looks like. So here what I have done, I have saved my data to a CSV file, right? So this data I'm coming like this data, I'm reading it from the internet. So every time it's not possible to read data from the internet because it causes like it takes up bandwidth. So this is a small file. This is around 4 to 5 MB file. So it's actually extremely easy to get, like easy to download every time. But we won't be getting small file size. We can get 100 MB, 200 MB if 1 GB, 1 TB file. So it's always a best option to best habit, I should say, to save the data, okay, into the CSV file into our system so that we can manipulate it. So I have saved the training set and the test set as a CSV file in my current directory that I am working. Okay, so if I show you, this is the data set, adult data set. See, both combined together is 5.51 MB. So this is the train data and this is the test data. Okay, so it's better to save the data set in our system so that we can do any kind of manipulation we want, and it is going to be faster to read it back. We don't have to download every time. So here what we are doing, we are reading the data set, right? So after reading the data set, so the data looks like this. Okay, first of all, let me explain you this part. These are the column names that got assigned to our data frame, which looked like this. Okay, after changing this, let me print this. Train set now looks like, okay, train set is this. Okay, so if you do train set dot columns, now if you print it, okay, column labels, okay, this is not defined yet. Execute this, and if I execute this, you can see this is the data. Okay, and we are saving this data as a CSV file. So this is how it looks like, and we are saving this as a CSV file. Okay, we are saving that as a CSV file, then again we are reading it. Okay, we are reading the same CSV file. So this is the head of the data looks like. Fine. Then after this, what I have done, I generally do this data.info. It gives the data type and the non-null count, right? So here you can just get a glance how your data looks like. Okay, so you have this data type, you have this as object, so this is a string, this is the integer, this is the object, this is integer, this is an object. So here you can identify that how many categorical columns you have and how many numerical columns you have. Okay, so data.describe, okay, this is like I generally run this to check the count, the mean, the standard deviation. Okay, the minimum value and the maximum value, these are extremely important for me for the deployment part. So you can just put a check, and so you can just put a check over there that the value does not go above 90 or the value does not fall below 17 in the deployment part, in the web part. Okay, so this is data.describe. and it gives us a brief about the data, and this contains all the numerical columns. Okay, this doesn't contain categorical values. Okay, this contain only numerical columns. See, age is there, age is numerical. Here F, NL, WGT, which is also a numerical column. Here education number, numerical column, right? So this works, this describe works only on the numerical data. Now, another thing, I do this also to check if there is any null value or not. So here it says about the non-null value, this code data.info, but this tells us that how many null values I have. Okay. So this tells us that how many columns have null values and I am supposed to handle those null values. So this gives us an overview of that. So this is correlation plot. So I have done a little bit of visualization, little bit. So this is actually, I cannot say this as a visualization. So what it is, so generally in machine learning, there are many problems that you have to handle in a data set. And one of them is called as collinearity. And I just wanted to check whether there is any kind of collinearity present in the data set or not, right? So as I can see, there is no collinearity present in the data set, and this is something that that is going to take some time to explain, and I'm going to explain this in a proper video. But what collinearity is, suppose you have two columns, okay, age and experience. So as your age increases, your number of experience also increases, right? So these two columns are dependent. So your age is increasing, your experience is also increasing. So don't you think that any one of these columns can be dropped, because those both of the columns are like so giving the same explanation? So you can drop the experience column and you can keep the age column, or you can drop the age column and keep the experience column. So your data got reduced by one column. Now processing will be a little bit faster. Okay, so this is what collinearity is. Now generally I go with a value count. Generally I check the target. So since this is a classification problem, you have also have to check the classes. So if I go up and if I check my data set, these are the columns that I have, and this is the particular class. Lesser than equal to 50k, lesser than equal to 50k. We have two classes for this. Okay, here you can see one particular class is shown, but we have two classes. So if I execute this, let me execute all of them. Info, data.info, data.describe, data.isNA, klib.plot. Okay. So here, as I explained, I can see that there is no collinearity, okay, because the value that is present is extremely small. If the value is greater than 0.7 or 0.8, then I can say 0.8 specifically, then I can say the data, there is collinearity in the data. Okay. And regarding this, generally I check the number of classes that is present. So as I can see, there are two classes that is present, that is lesser than equal to 50k and greater than 50k. And what value counts does, it also tells us the number. So the number of people whose salary is lesser than equal to 50k, that is 50,000, is nothing but 24,720 people has this salary lesser than equal to 50k. And the number of people greater than 50k is 7841. So you can see there is an imbalance in the data set. This number is extremely high and this number is extremely low. So around 3 times, right? So I just did that how many times like the data has to be multiplied. So it is 3 times. Okay, so you can see that 7 into 3, if you do 78 into 3, if you do, you will get somewhere around this value, right? So there is a imbalance in the data set. So if I check the number of times this class is less, is nothing but 3.1526 times. Okay, it gives us the ratio of it. So now what we are supposed to do, we are supposed to pre-process the data. So first of all, since this is an imbalanced data set, we are supposed to balance it. So here what I am doing, I am just multiplying the data. This data is present, okay, this many items are present in a data set. I am multiplying it by 3. Here I am filtering out the data. The data, let me show you, let me execute this and let me show you how it looks like. Okay, so these are all the data which are having this particular class greater than 50k, right? I am picking this data and I'm multiplying this by 3. Okay, so like if there are 10 items in my data set, if I multiply by 3, I'll get 30 items. Okay, it's that simple. So I'm multiplying the number of rows. So for example, I'm just filtering out the data which are having class as greater than 50k, and here I am just doing a multiplication. And here I am just creating a new data frame and I am putting all my data, the multiplied data and the second class data, okay, all of the data together over here. So this data greater than 50k, okay, I am filtering out, I am storing that over here, okay, and I am just multiplying the number of rows using this line of code, okay. And next now what happened, I already have a data set which has this data greater than 50k data 3 times. Now what I have to do, I have to filter this class also. So here I picked up those people whose income is greater than whose income is less than 50k, and I'm just saving this to the same data frame, right? And I'm doing a head. So here you can see the data is present, I think. Yeah, greater than 50k, greater than 50k, greater than 50k. And okay, if you are not able to understand this, I'm gonna explain. Just check this. If I again do new data wedge class dot value counts, you can see it's nothing but greater than 50k. This many items are there. Lesser than 50k, lesser than equal to 50k, this many items are there, and greater than 50k, this many items are there. Okay. So now you are able to understand. So what I did, this data was less. I just repopulated the data. Okay, I just repopulated the data with the same data. The data is same. Here, this 7841 data that was present. Okay, so what I did, I just repeatedly populated the data. Okay, so 7841 data into 3, so it gave me 3 times the same data frame. Okay, and I added the actual data, I mean I added this data also, which is lesser than equal to 50k. Okay, so now you can see 24720, and it is 24720, and this is 7841. Now this is 2352. Okay, so now the data set is balanced. Okay, I hope I am able to explain and you are able to understand. If not, just ping me in the comment. I am trying my level best to explain this. Okay, this is done just to make the data set balanced. Now if I find out the ratio of this, you can see I'm getting someone around 1. So 1 means that it is balanced. Okay, it is somewhat, it is balanced. I should say it is balanced properly, not somewhat. So now if I execute this, value counts. Okay, new data is not defined. I have not executed this part. If I execute this, okay, now the next thing is you have to divide the data into numerical columns and into categorical columns. Okay, so this is doing that. So I know already which are my numerical columns and which are my categorical columns. Okay, so you can divide this data like this. Okay, so this data is divided. Now you can just find out from here. If I come over here, you can just simply do new data dot d types. It'll also tell you these are the categorical value, these are the numerical value. Okay, So it is extremely easy to find out. But you can do a small trick to find out this. You can do a small trick, like, you know, these are my categorical data, these are my numerical data. So if there are suppose 100 columns, so you have to copy paste one by one, so that is extremely tedious, right? So you can do a simple trick which I'm going to show. Okay, so here you can see, you can do this to get the age, FLNGT, education, capital gain. I have done this to get the value of, to copy this. Okay, I can copy and I can paste over here and it's done. Now if I want the categorical of data, categorical columns, I can do this and I'll get this, right? So this is extremely simple. I am gonna keep this code over here. Okay, this is going to help. So this is how you can find out the numerical column and you can find out the categorical column. We have divided the numerical column and the categorical column. Let's execute. Okay, so what I am doing over here, if you see the target column, let me show you the target column first. This is my target column. If you see the target column, or if I do class wage dot value counts, if you look carefully, you can see there is a space lesser than equal to 50. The space is there, right? Okay, the space is there. I don't want that space to be there. So I wrote a script which is able to handle the space thing, right? The space, and there are some dots also that I found out. So these are handling those small things. So there are some spaces in the names, so I'm just removing the spaces. Okay. So for example, for I in categorical column, so there are some data in categorical data. There are some data, okay, with the same name, but there is a space. For example, there is a class 1, there is a class 2, and for example, there is space class 1. So you can see the class 1 and the class 1 are the same thing. They are not two different classes. Only because of this space, they are being treated as a different classes. So I have found that and I just did this to remove spaces from heading space and trailing space. And this is done to remove spaces and dots from my target data. Okay. So let me show you why this dot. This is in the adult test.csv. Okay. This file you can see there. This is the data. If I zoom in, you can see there is a dot provided at the end, right? I don't want that dot to be present. So in my training file, this dot is not there. There is a space. In my test file, there is a dot present. So we have to make things consistent. So I have written this code, this particular code to handle this problem, this space and dot. Fine. So now here I have also seen there are some value that is present in the data. For example, I can see there was some question mark that was present. So it actually looks very bad. So what I did, I replaced this question mark with a different value as other. This is a value. So if there is any kind of question mark that is present, it is going to change it to other. Okay. Now, for example, in work class, what does this question mark says that it doesn't know which work class that particular person belongs to. So what I have done, I have just gave other because it's simply we don't know. So in work class and occupation, I found out this and I just replaced it with a other value. Now if I check, if I do the head, you can see this is the data. Okay, this is sort of a cleaned data, I would say. It's sort of a cleaned data because we don't have null values over here. Null value, as I showed before, we don't have any null values, so we don't have to handle null values. So that is a great thing. This is something you won't get in a real data set. There is going to be null values, but in this data set there is no null value, so that's actually good. Now uh, I have shown you this little pre-processing that I have done. So I have shown you the data, how it looks like, and the little pre-processing that I have done. So I'll keep the video till this end, and in the next part I'm going to talk about the pipelines, the transformers, the machine learning, and the deployment. Okay, so I hope you are able to like understand this, and hopefully you are able to like it. And if you are able to understand and like it, so give a thumbs up, and thank you for watching, and I'm going to see you in the next video.